Okay, this is the recap of the last unit we just did a test on. Okay, so number one, what do those symbols even mean to you? Absolute value. Do you remember what the absolute value all meant? If you absolute a positive number, what happens to it? Stays. Yeah, positive. If you absolute 0, stays. And if you absolute a negative number, then it changes. Positive. Okay. Algebra, let's get the absolute alone here. Okay, I'm going to first add 5. Then I'm going to divide by 2. Okay, so now I'm ready to say, what could I have had inside those brackets? I could have had an 8 or a negative 8, right? Because the absolute of 8 gives me 8, the absolute of negative 8 gives me 8. So now I'm going to drop the brackets and say the inside stuff could have been an 8, or the inside stuff could have been a negative 8. But do you see how at this point, now I don't have brackets. So some of you put the brackets in the wrong spots on your test. Okay, the math is to add 1 and divide by 3. Add 1, divide by 3. Okay, question 2. This is where I have 3 equations, so I'm going to start with just labeling them to organize it. So 1, 2, and 3. When I first look at all these equations, is there one letter that is specifically maybe easier to get rid of than another letter? Z's. Okay, so I'm going to pick 2 equations. Doesn't matter, you just pick. So we go 1 and 2. Write them out. So how am I going to get rid of those z's? So you either have adding or subtracting them together. So if those are different, I would add. Okay, so adding makes 4x plus 2y equals 12. Which is now my 4th equation, because it's a new equation. Okay, what should we do now? Let's do 1 and 3. Yours would have been easier, which is why I'm doing the harder one. Just to make sure we get a subtraction in here. So 1 and 3. So when I look at the z's this time, they are the same. So once they look the same, I subtract them. Okay, so 1 subtract 4, that's -3, plus y equals 1. Now that is my 5th equation. Okay, so I'm going to look at just 4 and 5 now. Which letter, the x or the y, would I make the same? So if I was looking at the x's, I would think I'm have to times this by 3 and this by 4 to make them both 12. That works. But I think this is easier because all I would have to do is times this by 2 to match. So I'm going to leave equation 4 alone. And I'm going to times the 5th equation by 2. Don't forget to times everything though, right? Which includes the 1, because that's where people forget to times. Okay, I am going to get rid of the y's, so I will have to subtract. Okay, be careful here. What would you get? 4 subtract -6. That's actually a 10, right? Because the subtract negative adds it. And 12 subtract 2 is 10. Therefore, x equals 1. Okay, tell me an equation I can go to plug that in. 4 or 5. Those are your 2 options. When I look, I'm going to go to 4 because then I just don't have to deal with any negatives at all. So that's why I'm picking it. So 4 times x, which is now 1. So 4 plus 2y. Okay, now that I have x and I have y, where do I go to plug in to get z? 1, 2, or 3? Pick which one looks the easier one. I don't know, I'm just going to go with 1 here. So equation 1, x, which is 1, plus 3y, which is 4, plus z equals 16. And I'm getting a 3. Okay, question 3. Okay, when you're doing a system of equations, then you can ask yourself, can I substitute something in or can I set them up to eliminate? Those are your 2 options, or graphing, but we're not going to do that one. So which one would this one look like? Should I replace substitution? Okay, if y is equal to x squared, then I can replace that y with an x squared. Okay, what do I do with this once I have an equation that looks like this? Zero it out. So one side has to be 0. So I'm going to be moving that. Okay, so when I move it, I get a 4x positive and a minus 5. So now I look, can I factor? That'd be my next question. So if I tried to do factoring, it would be a simple trinomial technique. Multiplying to 5. So you only have 5 times 1. And can you get a positive 4 out of that? So x equals negative 5, x equals 1. Okay, this is not the answer though. This is almost there. I gotta plug this in. So if x is negative 5, what is y? So if x is negative 5, y is negative 5 squared, which is 25. If x is 1, plug it in. What is 1 squared? 1. Okay, you could also plug it into the second equation. It should still be the same. Okay, question 2. What would you pick on this one? Substitution or elimination? I think elimination. What do you want to get rid of? The x's stuff or the y stuff? I think I'm just going to do that. I'm going to get rid of that. So what would I do to get that out? I would add. Okay, so that makes 2x squareds gone, and this makes 50. Divide by 2. Okay, how do we write this answer? This is the best class I've ever had that answers this question. Plus or minus 5. Okay, now I'm going to do some plug-ins. So I'm going to do the plug-in. So x squared can get replaced with, I actually can just plug this straight into x squared. 25. When I minus 25, that is 9, which makes y plus or minus 3. Solve. So on this one, I'm going to first figure out where does it equal 0. So to get it there, I'm going to factor. Okay, so you got your types. Always start with your types. We got them all memorized. GCF, simple trinomial, complex trinomial, difference of squares. So GCF, take out an x. Everything has an x in it. X squared minus 2x minus 8. I got to figure out where does it equal 0. Now I'm going to do a simple trinomial multiplying to 8. Got something that multiplies to 8. 4 times 2. So x is 0, 4, negative 2. So on a number line, on those x values, the y is exactly 0. Okay, now I'm going to go into the zones and do a test. So I'm going to go 6. I'm going to test 6. How many plugins do I have to do here? There was 3 multipliers. So once I plug 6 into the 3 brackets, I get positive, positive, positive. So those 3 positives timesing would make a positive. Okay, now I'm going to test something like 2. 1, 2, 3, whatever you want in that zone. So 2, positive. 2 minus 4, that's negative. 2 plus 2 is positive. So if there was 1 negative in there, it's negative. Okay, now I'm going to go with a -1 in this zone. So negative makes negative, negative, positive. So that would make 2 negatives positive. And in this zone, I'm going to test -5. So it would make negative, negative, negative. 3 negatives, negative. Okay, less than 0 is what I'm looking for. So that's what I'm looking for. Less than 0, so negative zones. So where am I negative? I'm negative in those zones. So how do I write them as a domain? Negative infinity up to the -2. Round bracket. And then this one would be from 0 to 4. So they're round brackets because you can't be equal to 0. And if you hit there, if you hit exactly 4, you're equal to 0, and you can't be. Okay, what numbers are we putting on our number line here? X equals 3, 1, and -2. And I don't need to repeat it, just -2. When I'm doing a plug-in, I'm going to have 4 things getting multiplied though, right? There's 4 brackets. Okay, so I'm going to test 5. 5 minus 3, positive. 5 minus 1, positive. Positive, positive. 4 positives. I'm going to test 2. 2 minus 3, negative. Positive, positive, positive. 1 negative is negative. I'm going to test 0 in this zone. So 0 minus 3, negative, negative, positive, positive. So I'm just looking at the numbers. -3, -1. So 2 negatives make positive. And the last zone, I'm going to test -4. Negative, 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 negative. 4 negatives make positive. So we had two positives in a row there. Okay, what's the answer here? We want to be greater than or equal to 0. So this zone would work, positive. Right on this would work. Oh, and then we can just continue and on. So we can actually combine those zones together because there's no stopping. If there was no equal sign, I would have to stop and continue separately. And that zone works as well. So from negative infinity all the way up to 1, including everything in that. And then this zone would be 3 to infinity. Okay, so we're going to graph these two systems. So we're going to need algebra because we want to end up like this when we graph a line. mx plus b, that form y equals. So we want y alone. Obviously we don't have an equal sign, we have a different sign, but that's the goal, to get y alone. Okay, so here's the first line. I'm going to keep 3y less than, I'm going to move the x piece over, so negative 2x. I'm going to move the 15 piece over, so plus 15. I'm going to divide everything by 3. So y is less than negative 2/3 x plus 5. Okay, so I'm going to graph. I'm going to put a y-intercept at 5. And now I'm going to go a slope down to right 3. So there's 2 points that are on my line. And what should I do here? Dashed or solid? Dashed. Because I am not allowed to be equal to that line. And I'm going to be less than that, so I have to pick a direction I want to go. So less, so I will want to be in that direction. I'm not going to shade quite yet because I have to figure out the other part. Okay, second line. So there's, I just wrote it down so I can do some algebra. Okay, ready? Keep the y's. So negative 2y, keeping. Less than or equal to. Move the x part over. Move the 8 part over. Obviously on those I switched the signs on them when I moved. Now I'm going to divide by negative 2. And does anybody remember this rule? What happened with that? I divided by negative, so I have to, the sign gets flipped. So this is just y now. What would happen with this slope? What does 2 negatives make? Positive, so I can just cancel the 2 negatives. And then minus 4. All right, so that's where I'm going to start, the negative 4. y-intercept. Up 3, right 2. Up 3, right 2. And then I'm going to ask myself, should I do a dashed line or a solid line? So this one is solid because it says I'm allowed to also be equal to it. And then greater is this way. So which shaded part would work? Anything in this zone. Any coordinate in that area would work in both inequalities. So you can always try to see some points if they work. So for instance, the coordinate 0, 0 should work. So if these were both 0, is negative 15 less than 0? Yes. If x and y were both 0, is negative 8 less than or equal to 0? Yes. Okay, graphing in absolute. So we had our 3 rules. Where it's positive or 0, overlap it. So this part would stay. And this point would also stay. So anything that was 0 or positive stays. Now, anything that is a negative height will have to move to a positive height. So then this was at negative 2, so now it will go up to positive 2. I changed that negative part. Okay, graphing a reciprocal. So the first thing I do is a height of 0 because the reciprocal is 1 over 0. What is this number in math? How do we say that number? What is 1 over 0? How do we say it as a number? Undefined. It's an undefined number. How do you graph undefined? Do you remember how to graph an undefined number? An asymptote. That's how you graph undefined. So that would be right here and over here. Next, I look for heights of 1 or negative 1, because what happens when I reciprocate 1 or negative 1? What happens to them? They stay. They don't do anything. So where would I see those heights? Right here and right here. Okay, the last part is I fill in the pattern. So if I'm the farthest away from 0, I'm going to move that to the closest away. And if I'm close, I'm going to move it far away. So I'm going to put my pen right on this coordinate. It is so far in that section the farthest away, which this coordinate is 0, negative 4. Where would it move to? 0, comma, negative a quarter. So it was the farthest away from the 0 line, so now it's the closest. And then what are we going to do? So from there, we're going to move away from 0, away, 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 away. Because that's the pattern. I was going to 0, so now my arrow is going away from 0.